Hi, I'm Jerome from Cognito Academy, and in this series, I'll be going through some interesting physics questions. Let's take a look at this question, which states that a ball is released from the top of an 80-meter building, and that given that the gravitational field strength G is 10 newtons per kilogram, and ignoring the effects of air resistance, what is the time taken for the ball to fall to the ground? So let's try to first visualize this. We start off with the ball 80 meters away from the ground, being pulled by gravity, so it slowly accelerates downwards until it eventually hits the ground. The fastest way to answer such a question, which is especially important during time conditions in the exam, is to find which variables we know and which we don't, and then use a suitable formula to solve for the variables that we don't know but we're trying to find. So first we have to define which direction we set to be positive. Here I've defined downwards direction to be positive, but you could also choose to do it the other way. But setting downwards to be positive is slightly easier because you don't have to deal with negative values because the ball is traveling downwards. U, our initial velocity, is 0 because the ball is released from the top of the building, not thrown with some initial velocity. Our acceleration here is given by the gravitational acceleration. So our acceleration A is given by G, which is 10 newtons per kilogram. Note that the sign of A here is positive because the gravity is pulling the ball downwards, which we have already defined to be positive. Our displacement from our original position S is 80 meters. Same thing here, note that because our displacement from our original position is downwards, which we define to be positive, the sign of S is also positive. Now let's consider our knowns. We have V, our final velocity, but that's not really important because we're not asked about that. T, the time taken for the ball to fall to the ground, is really what we're after. So we should find some equation that contains only the variables U, A, and S, which we know, and T, which we don't know but we're trying to find. One good equation is S equals to UT plus half AT squared. It's good because it contains U, S, and A, and then it contains T. So plugging in the values and solving for T, we have on the left hand side S, which is 80, UT, which is 0 because U is 0, and half AT squared, which is 5T squared. And then rearranging this, we get T squared equals to 16 and T equals to 4 seconds. So our answer here is C. If you like this video, hit like and subscribe, and head over to our channel for more videos like this.